This is something you have done in Algebra 1. You definitely did this. But only probably did 2 by 2, like binomial by binomial. You probably did not do anything more than that. You may have done 3 by 2, but certainly not anything more than that. In Algebra 2, you need to be able to multiply any type of polynomial by any other type of polynomial. So a 3 by 3, a 4 by 4, 2 by 3, whatever. So we are going to do that. But before we get into that, we're just going to do a little review because I want to make sure we remember how to do that. So what I want you to do now is pause the video real quick and use a method of your choice to find the product. So you tell me how you would find 3x minus 4 times x plus 5 if you remember. I want to see if you can remember it. And right now I will go ahead and do that. So hopefully you have this done already. 3x minus 4 times x plus 5. Some of you may have learned the FOIL method, F-O-I-L. If you did, we're going to try and totally get rid of that method because that only works for binomials. 3x minus 4 times x plus 5. It does work for this, but it's not going to work for the ones we're going to do in this class. So we're going to totally get rid of that FOIL, but really what it is distributive property, and we're going to learn a new method to do more complicated ones today. But anyways, you do the first times the first. 3x times x is 3x squared. 3x times 5 would be 15x. And then negative 4 times x, negative 4x. And then negative 4 times 5 would be negative 20. So you'd get 3x squared plus 11x minus 20. You also could have done, set up one of these. You may have set up a box. And you put the 3x and the minus 4, and then you put the x and the plus 5 like that. 3x squared plus 15x. You may have learned it like this. Minus 4x and then minus 20, and of course you get the same answer. 3x squared plus 11x minus 20. Okay? That's just a review. What you're going to learn in this lesson is called the tabular method for multiplying. And it kind of looks like if you learn like the box area model for multiplying, it's kind of like that. Obviously it's the same box, but it's going to be just a little bit different. It's going to be where you're going to put these things. And you may have done this in Algebra 1, depending on, it depends. It just depends on whether your teacher did it this way or not. But instead of using the top and the left side, you're going to use the top and the right side to put the two given polynomials, in this case binomials. So it's going to be 3x minus 4 on top, and then x plus 5 along the right side. And then you'll see these arrows here, and I'll get to those, what those are. So basically we already did it. 3x squared minus 4x. And then it's going to be 15x here, and then negative 20. All right. Now, the reason why these arrows are here is because you will see, and the reason why we do this method is because you will see the like terms all line up along that diagonal. Now, there isn't really a diagonal here, it's just one box. So 3x squared is the diagonal, and that leaves you with 3x squared. See this arrow here? If you kind of follow it back, you get these two boxes right here. See how they line up? I'm going to kind of circle them this time. There's your like terms. They line up along that diagonal. 15x minus 4x, 11x. And then there's the negative 20 that lines up with nothing, just itself, and that's negative 20. So the only like terms there were for this one were right here in the middle. And that's because it was simple. It was a binomial. There's just going to be two like terms. But the more terms you have to start, the more like terms you're going to have. So there's our answer right there. Your answer is along the outside here. 3x squared, again for the third time, 3x squared plus 11x minus 20. All right. So now that you understand the tabular method a little bit, we're going to do a 3 by 3. X squared plus 3x plus 1, and x squared minus 5x plus 2. All right, so let's do this. We got 9 multiplications to do. X squared times x squared, x to the 4th. 3x times x squared, 3x to the 3rd. 1 x squared. X squared times negative 5x right here. X squared and negative 5x. Multiplication is negative 5x to the 3rd. 3x times negative 5x, negative 15x. 1 times negative 5x, negative 5x. X squared times 2, 2x squared. 3x times 2, 6x, and 1 times 2 is 2. Now, you can see a little better now. See the arrows? There's nothing to combine with x to the 4th. It's just x to the 4th. Both of your x to the 3rds are along this diagonal here. See that? They all line up along the diagonal. And you combine those together and get negative 2x to the 3rd. Your x squareds, oh, this should have been x squared. That's why, see, I know I made a mistake. That's another reason. You catch mistakes. Maybe you already caught it. 3x times negative 5x was negative 15x squared. And kind of glad I made that mistake because it kind of shows you that, wait a minute, if the terms don't line up along the diagonal, then you know you did something wrong, okay, and they didn't. So I know these should all be x squareds. X squared and 2x squared is 3x squared, but then negative 15x squared gives you negative 12x squared. And then here's my x's lining up along the diagonal. 1x and then 2. So my product here, final answer, is going to be x to the 4th minus 2x to the 3rd minus 12x squared plus 1x plus 2. All right, that is your multiplied, sorry about that. Your next screen press will be a right click. All right. Got it. All right, example 3 and 4, and then we're going to be done. Tabular method to do this. What's different about this one is, notice, I have x squared, I have 3x and 1, I have x squared minus 2. It looks like it'll be a 3 by 2, a 3 by 3 and then 2 along. However, if you want everything to line up along that diagonal, which is what the tabular method's all about, if you don't have them lining up along the diagonals, it's not the tabular method. You have to make sure every term is represented. So like we did before, when we did synthetic substitution and when we did adding and subtracting polynomials, you want to make sure everything is represented. I have x squared, I better have x squared here. I have an x term, I better have an x term here. I don't. You're going to have to put a 0x in there. So your table does still need to be a 3 by 3. All right, so let's kind of put it over here. You're going to make your own table. This is kind of hard to do with the pen I'm using here, so I'm going to do the best I can. Everyone draw on their table. So we have x squared, 3x, and 1. And then I have x squared, 0x, and negative 2. Got it? Good. So x squared times x squared, x to the 4th. Let's go down. X squared times 0x, 0x to the 3rd. X squared times negative 2, negative 2x squared. 3x times x squared, 3x to the 3rd. 3x times 0x, 0x squared. 3x times negative 2, negative 6x. 1 times x squared, 1 times 0x, 1 times negative 2. Let's make sure everything lines up. That should give you something, that should give you something, that should give you something, and that should give you something, and so should that. So x to the fourth, this lines up, 3x to the third. This all lines up here. 1, 0, and negative 2 is negative 1, and so just negative x squared. This is negative 6x, and this is negative 2. So my product is going to be, I'm just going to write it down here, x to the fourth, oops, go off. Oh, of course that happened. I'm going to put it over here. X to the fourth plus 3x to the third minus x squared minus 6x. What was it? Minus 2? Whatever that was. Yeah, minus 2. All right. All right, so for example 4, we're going to use the tabular method to multiply. And so we're going to need it looks like 3 by 2, but it's not, because there's missing an x squared here. There's missing an x squared term, so there's actually 4 terms here, and here we're missing the x term. So there's actually 3. This is a 4 by 3. A 4 by 3. So I'm going to draw a 4 by 3 here. Okay, so and then 4 we could chop down the middle, chop down the middle, chop down the middle. Okay, so we have 2x to the third. We have 0x squared. We have 3x, and we have negative 4. I'm going to get rid of this here because that's going to get in the way. All right, and then we have x squared. Remember, 0x and then 3. All right, so you're just multiplying this times this, goes here, 2x to the fifth. And then we have 0x to the fourth. We have 6x to the third. 0x to the fourth. 0x to the third. 0x squared. This whole row, our whole column is going to be zeroed. 3x to the third. 0x squared, and this whole row is going to be 0. This will be 0x, and then 9x here, and then negative 4x squared, 0x, and then negative 12. All right, so then we're going to combine our diagonals. All right, so we get 2x to the fifth. This is nothing. This is 9x to the third. This is negative 4x squared. This is 9x, and then negative 12. So that is your answer there. I'm just going to change colors and write it all out. Your answer is 2x to the fifth plus 9x to the third minus 4x squared plus 9x minus 12. Box that up, and that's it, and I will see you in class tomorrow.